Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to go over how to multiply complex numbers. Now, working with multiplication with complex numbers involving I, just like working with the variable x, except when we multiply I times I and get I squared, remember that I squared is equal to -1, so we'll replace every instance of I squared by -1. Basically changing the sign of the term that it's with. Let's try several of these. We'll start with just two imaginary numbers, 8i times 6i. Multiply 8 times 6, and that's 48. I times I is I squared. Now, I squared is -1, so this is the same as 48 times -1, or -48. When you see that 48i squared, what I want you to think about is, okay, the 48 is going to stay, but it's going to change its sign to be a -48, and we'll get rid of the I squared by doing that. For the second example, number 13, -5i times 3i. -5 times 3, that is -15. I times I is I squared. So this is like -15 times -1, multiplying a -15 by -1. That result is +15. Again, you can think of it this way, -15 I squared. To get rid of the I squared, I need to change the sign of that term, +15. The next couple of examples involve distributing. So we're going to distribute an imaginary number to a complex number. That's what we're multiplying. First one, number 14, is 2i times 7 plus 6i. I begin with 2i times 7. And that is 14i. Then I've got 2i times 6i, that is plus 12i squared. By what we were talking about up above, that plus 12i squared can be rewritten as -12 because it's 12 times -1. So this is 14i minus 12, but we typically write our complex number solution with the imaginary part last. So I'm going to switch these terms around, and I'm going to put the -12 first, plus 14i last. Number 15 is similar. We've got -5i times the complex number 8 minus 9i. -5i times 8, that is -40i. -5i times -9i, that's plus 45i squared. That is the same as -40i minus 45, because 45 times I squared is 45 times -1, -45. And then again, I'm going to rewrite these terms so that the real part is first, -45 minus 40i. Typically, you're going to be asked to write things in a plus bi form. That means the imaginary part gets listed last. Now we're going to multiply a complex number by a complex number, and for many of you, this is the type of multiplication you know as FOIL-style multiplication. We begin by distributing the first term in the first set of parentheses to every term in the second, and then we repeat it for the second term in the first parentheses. So 3 plus I times 9 plus 2i, I'll distribute the 3 first. 3 times 9 is 27. 3 times 2i, that's plus 6i. Then I distribute the I times 9, that's plus 9i, and I times 2i, that's plus 2i squared. There are some like terms to combine, and I need to deal with this I squared. 27, 6i and 9i I can combine to be 15i plus 15i, and then plus 2i squared is the same as -2, so minus 2. And finally, I've got two like terms to combine. 27 minus 2, that is 25, plus 15i. By the way, I haven't said this yet, but we can't add the 25 and the 15. The 15 is being multiplied by I. That prevents us from adding it to the 25. Number 17, basically the same idea. Maybe I'll show you some ways that we can shortcut this a little bit. We'll start 2 minus 5i times 6 plus 3i. We'll distribute the 2 first. 2 times 6 is 12, plus 2 times 3i, that is 6i. Okay, now when I distribute that negative 5i times 6, I get negative 30i. And negative 5i times positive 3i is minus 15i squared. So I'm going to combine 6i and negative 30i. And at the same time, I want to think of minus 15i squared as plus 15, which I can then combine with the 12. 12 plus 15 is 27. And 6i minus 30i, that is minus 24i. There's our answer as a complex number. Now notice in the problem 16, I took a couple extra steps to get there. Do whatever is easiest for you. Problem 18, we're multiplying 8 plus 7i times 8 minus 7i. Now this product is going to show us something interesting at the end of the day. Let's begin by treating it like a normal problem first. We're going to distribute 8 times 8, that is 64. 8 times negative 7i, that's minus 56i. Then distribute the 7i. 7i times 8, that's plus 56i. And 7i times negative 7i, that's minus 49i squared. Notice that the two terms in the middle are opposites of each other. And when we combine those, they will combine to be 0. That means that this is not going to be an imaginary number. Our answer is going to be a real number, because minus 49i squared, that can be rewritten as plus 49. And 64 plus 49 is the real number 113. Now these two numbers, if you look at them before we multiply, let me erase some of this. What you'll notice is that the two parts are the same, except for the sign in the middle is different. 8 plus 7i, 8 minus 7i. These are what we call conjugates. And whenever you have something of this form, a plus bi times a minus bi, that is always going to be equal to a squared plus b squared. The two middle terms will cancel each other out, and the negative b squared I squared becomes plus b squared. So you can use that formula to simplify this out. In problem 19, I've got 6 minus I times 6 plus I. There my a is 6 and my b is 1. So I know right away I can think of this as 6 squared plus 1 squared. And that's 36 plus 1, or 37. By the way, if I did the FOIL style multiplication, I would have had 36 plus 6i minus 6i minus I squared. The two terms in the middle are opposites, and minus I squared is the same as plus 1. That's where the 37 comes from, 36 plus 1. Those conjugates will be important in a later video that we'll be doing for this section. Okay, what's left? I've got a square of a complex number. So 2 plus 3i quantity squared. The first step is the important step. If you rewrite this as 2 plus 3i times 2 plus 3i, we've made it into a problem that we know how to do already. So rewriting it by taking that idea of being squared as multiplying it by itself, then I use that FOIL style multiplication, distribute the 2, 2 times 2 is 4, plus 2 times 3i is 6i, then distribute the 3i, 3i times 2 is also plus 6i, and 3i times 3i is plus 9i squared. We're going to combine the two 6i's together, and also plus 9i squared is really the same as minus 9. So 4 minus 9, that is negative 5. 6i plus 6i, that is plus 12i. Number 21, same idea, 8 minus 11i, quantity squared. So that's going to be 8 minus 11i times 8 minus 11i. And by the way, these aren't conjugates because the sign is the same in both, right? It's not 8 plus 11i and 8 minus 11i. We've got two of the same sign. So we can't use that conjugate rule that we had. Distribute the 8. 8 times 8 is 64. 8 times negative 11i is negative 88i. Now distribute the negative 11i times 8. That's also minus 88i. Negative 11i times negative 11i. That's going to be positive 121i squared. I can combine these two middle terms. And again, that 121i squared is really going to turn into negative 121. So combining the real parts first, 64 minus 121, that is negative 57. Do that on your calculator. And then negative 88i minus 88i is minus 176i. So that's how you multiply complex numbers. Just remember, it's like working with variables, except when you see an I squared, that turns into a negative 1. Also, that rule for conjugates, right? It's kind of like difference of squares. We've seen that before in our math background. We can multiply the real part by the real part, and then minus the imaginary part times the imaginary part, and eventually that turns into that formula a squared plus b squared. Right? That's it for this video. We'll see you in the next one.